Every AI chip in the world, from NVIDIA's GPU to Apple's processors, depends on a single industry that almost no one talks about. Not software, not design, but manufacturing. Because designing chip is one thing, actually building it is something different entirely. In the previous episodes, we explored two critical components of artificial intelligence. The GPU, which performs calculations, and high bandwidth memory, which feeds data to the processor. But these chips do not exist on their own. They must be physically manufactured, atom by atom, inside some of the most advanced facilities ever built. Facilities so complex, so expensive and so precise, that only a handful exist on Earth. These facilities are called semiconductor foundries. A foundry is a factory that produces computer chips designed by other companies. Companies like NVIDIA, AMD, Apple and Qualcomm design chips, but they do not manufacture them. Instead, they rely on foundries to turn digital blueprints into physical silicon. And this separation between design and manufacturing defines the modern semiconductor industry. A big barrier of entering this industry is cost, and this cost appears long before full-scale production. Even in university programs, access to real semiconductor manufacturing costs tens of thousands of euros or dollars. On nodes such as 7 nanometers, even a minimum prototype design can cost 50,000 euros for a single test run. And that is just for experimentation, before manufacturing at scale, before packaging, before loss of yield. And this is why semiconductor manufacturing is not just difficult, it is economically inaccessible to almost everybody. This is not an industry you can casually decide to enter. At the core of chip manufacturing is a process called photolithography. Imagine trying to draw billions of tiny circuits onto a piece of silicon, each smaller than a virus. That is essentially what chip manufacturing does. Layers of material are deposited, etched, and patterned repeatedly, sometimes over 100 times, all to build a single chip. Each layer must align with near-perfect precision. Even a microscopic error can render the entire chip useless. But the process itself is only part of the story. The environment where the chips are built must be controlled to an extreme level. Semiconductor fabrication plants, often called fabs, are among the cleanest places on Earth. The air inside these facilities contains far fewer particles than even the cleanest operating rooms. Because at a nanometer scale, a single particle of dust is massive, and therefore catastrophic. A single particle can destroy an entire chip. These factories also consume enormous amounts of ultra-pure water. Water is used constantly in order to clean wafers between manufacturing steps. But it's not just any water. It must be purified to such a degree that even trace minerals are removed. The air, the temperature, the humidity, the vibration of the building, everything is controlled with extreme precision. Even the slightest disturbance can affect the outcome of the chip. Engineers working inside these facilities wear full bodysuits in order to prevent contamination. Not because the environment is dangerous for humans, but because humans are dangerous for the process. A single hair, a breath, or even a skin particle can compromise production. These are not just factories. They are controlled environments pushing the limits of physics, chemistry and engineering, all at once. This is the most precise manufacturing humanity has ever achieved. Modern chips are measured in nanometers, billionths of a meter. At this scale, physics itself becomes a challenge. Electrons behave unpredictably. Heat, leakage and quantum effects begin to matter. Manufacturing at this level is not just engineering, it is pushing the limits of what is physically possible. One of the most critical technologies enabling modern chips is called extreme ultraviolet lithography, or EUV. And EUV machines use light with an extremely short wavelength in order to carve patterns into silicon at nanometer scale. These machines are among the most complex devices ever built. One of these costs over hundreds of millions of dollars. And they are produced by a single company in the world, ASML. At the center of this entire system sits one company, Taiwan Semiconductor Manufacturing Company. TSMC is not just a manufacturer though, it is the backbone of the modern semiconductor industry. And while companies like NVIDIA, Apple and AMD design the most advanced chips in the world, it is Taiwan Semi that actually builds them. And today, TSMC produces the majority of the world's most advanced semiconductors. At leading-edge nodes, such as 5 nanometers and below, it operates years ahead of most competitors. This lead is not accidental. For decades, Taiwan Semi has invested tens of billions of dollars every year into manufacturing. It has built deep relationships with equipment suppliers such as ASML, as well as optimizing every step of the fabrication process. And the result is something extremely rare in modern industry, a near monopoly at the cutting edge. And if you are building the most advanced AI chips in the world, there is effectively only one place that you can go. This concentration of capability gives TSMC enormous strategic importance. It means that the future of artificial intelligence depends on a small number of factories, mostly located on a single island. Today, much of the world's most advanced computing power depends on a small number of factories located in Taiwan. This concentration creates one of the most critical supply chain risks in modern history. Governments around the world are investing billions to build domestic semiconductor capacity. But catching up is extremely difficult, as building a leading-edge foundry can take years and cost tens of billions of dollars. Just like GPUs and memory, manufacturing has become a bottleneck. You cannot simply increase chip production overnight. Each new factory requires advanced equipment, highly specialized talent, and years of construction. As demand for AI accelerates, foundries are operating at the limits of their capacity, and the entire industry is racing to expand. So far, we have explored 3 layers of the AI supply chain: compute, memory, and manufacturing. But even after a chip is manufactured, it is not yet complete. Modern AI systems are not built from a single piece of silicon. They are assembled from multiple components: processors, memory, and other specialized modules. And these must be combined into a single system. This process is called advanced packaging, and it has quietly become one of the most important and most constrained parts of the entire AI supply chain. In the next episode, we will explore how these components are brought together. Because in modern AI, performance is no longer about only the chip. It is about how everything connects inside it.